Hello everyone, how are you guys? So let me do again some very important question in matrix theory. It's a question related to polynomials, not care polynomial, all that. Some basic polynomials, whether it has a root and what is related to eigenvalues and eigenvector and all that is really interesting question. And in this time students has done, and there is a 99% chances you are going to make mistakes or your calculation will be lengthy. So let's try to understand concept so that you will not make such things lengthy and feel comfortable while doing the test. Okay, let's come to the question. So question here is this: consider the matrix Ax equal to this 1 plus x square 2x and this all entry 3 cross 3 matrix. So what is the condition over x? X belongs to R. Okay, now Ax has eigenvalue 0 for some x belongs to R. Second, 0 is not an eigenvalue of Ax for any x belongs to R. Ax has eigenvalue 0 for all x belongs to R. Ax is invertible for every x belongs to R. Every, for all R, for any, right, for some x. These are the certain keywords. These are the certain keywords you should understand. So what? Let me go again. Ax is this. Ax has eigenvalue 0 for some x. Means can you find x? How is this is going to happen? 0 is not an eigenvalue of Ax for any x, but for all x. Ax has eigenvalue 0 for all x. Ax is invertible for every x. So all options seem same. How one can approach in less time, in confident way, so that your hand will not shake. Let's try to understand, right? So how to think here? I always start how to think. What will be our approach to answer this kind of questions, right? Let's see. What is you have given me? You have given me this. Ax is this. You have given me this, right? Let me recall a basic fact before answer to this question. Recall a basic fact. A polynomial of odd degree. A polynomial of odd degree will have with real coefficient. With real coefficient will have at least one real root. If you are considering the polynomial of odd degree in one variable, then it will always have, with real coefficient, will always have at least one real root. At least one real root. So, and if degree of your polynomial px is equal to 3, then number of real roots of px is either 1 or 3. I am considering all coefficients are real. Okay, so these are the real polynomials of odd degree. So if you have a real polynomials of degree, let's say n, then that can have at most n real roots. That's clear by fundamental theorem of algebra. And if that degree is odd, then always you can say that there exists at least one real root. So at least one real root is guaranteed, at most the degree. Okay, so that is the answer. So this is the basic fact here. Now let's come to answer here. So this is the basic fact related to polynomials and all. Why I have written this? You will be surprised that here they are asking about the polynomials and you are writing. They are asking about the eigenvalues. They have written the matrix. They are asking about the eigenvalues and you are writing about the polynomials. What's the benefit at all? Yes, there is. What is the determinant of Ax? What is the determinant of Ax? Tell me. Tell me the determinant of Ax. How you can find? Do the calculation. I know that you are going to do the calculation. That's I don't want to do. This is a 3-degree polynomial. So this is a some 3rd-degree polynomial, right? X cube and all that. Degree of this polynomial, even though if I say this px, so degree of px is 3. I am not interested in evaluating determinant of ax. I am just interested, this is determinant of ax is a polynomial in degree 3, right? So this is a degree 3 odd degree polynomial with real coefficient. So it will have at least one real root. That implies there exists alpha belongs to, let's say, lambda belongs to R such that P of lambda is going to be 0. There will be at least one real root for which P lambda is going to be 0. And how many real roots exist? Either 1 or 3, because the degree of this polynomial is 3. Degree of this polynomial is 3. So there will be at least one real root. At least one real root. Right? So this matrix for some x always have 0 as an eigenvalue. If you find, because the determinant of this matrix will vanish for certain x, because determinant of ax is a 3rd-degree polynomial. So if you have a 3rd-degree polynomial, then it will always have a real root. What do you mean by real root? It will become 0 for that real root. That means there exists x for which determinant of x will become 0. Hence 0 is an eigenvalue of ax for some x. I don't want to do Mazduri and all. We are mathematician. We are not like Bandhua Mazdur that we have to write all these expressions in ax and no, it's not. They are not asking about that. They are asking just a simple concept. Do you know the odd degree polynomial properties or not? What you can say about the 3rd-degree polynomial? Coefficients are from real. Yes, it will have either one real root or 3 real roots. That means if it has exactly one real root, that means there exists a unique real value. That means if I remove that real value, px is not going to be 0 from on R. Hence ax is invertible. Determinant of ax is going to be non-zero where ax is not equal to 0. How many points for determinant of x going to be 0? At most 3 value. Either 1 or 3, because odd degree polynomial have either one real root or 3 real roots. So if one real root if those real roots I will remove from a real number, I will have infinitely many real numbers. Uncountably many. So where determinant of ax is going to be non-zero. So 0 is not an eigenvalue of ax for any x. It's false. False. This is the negation of this. This is false. Ax has eigenvalue 0 for all x. They are saying doesn't matter which x you will pick. 0 is always an eigenvalue. False. This means you are saying that determinant of ax is going to be 0 for all x. Means you are saying that you have a 3-degree polynomial which is going to vanish for all x. Means you are saying a 3rd-degree polynomial have roots, infinitely many roots. All real number is going to be root of a 3rd-degree polynomial. It is possible? No. Any polynomial of degree n can have at most n real roots. Using that, ax has 0 as an eigenvalue for all x. False. 0 as an eigenvalue saying means ax equal to 0 for all x. Determinant of x equal to 0 for all x. When a 3rd-degree polynomial is going to vanish. That's false. Try to understand that. Don't do Mazduri. That's the difference. The way I teach and something else. Don't do this. Ax is invertible for every x belongs to R. What you can say that? Ax is invertible for every x belongs to R. Ax is invertible for every x belongs to R. No. No. Matrix is invertible if and only if determinant of that matrix is not equal to 0. But determinant of Ax is equal to 0 for some x, because determinant of Ax is a 3rd-degree polynomial. It must vanish at sum of x. So it fails to be invertible for some x. And how many such x? Either 1 or 3. Yes, if you remove those 3 points from real number, then Ax is invertible. Okay? So it's not about to just to do this kind of stuff. Try to understand. Trust me. Lots of students took lot of time to answer this question. It's just a matter of your understanding. Right? See how I have done. Even though I don't want to use the pen also. In this question, I don't want to use this pen. It's so easy question. They are asking, this is the 11-12 standard mathematics problem. If you ask to any 11-12 standard boys who know the polynomials of odd degree, they are easy to answer. They are easy to answer. So again I am going to do the options. Ax has eigenvalue 0 for some x, because determinant of Ax, just I'll write that determinant of Ax, the degree of this polynomial is 3, so it will have at least one real root, means there exists x such that determinant of x equal to 0, so 0 is an eigenvalue for some x. 0 is not an eigenvalue of Ax for any x. 0 is never going to be an eigenvalue of x for any x, no. This is odd degree polynomial, it must have, so 0 is not an eigenvalue of Ax for any x. False. Because 0 must be an eigenvalue for sum of x. Third number, Ax has eigenvalue 0 for all x. No. So because if 0 is going to be eigenvalue for all x, means you are saying that determinant of x equal to 0 for all x. Third degree polynomial has infinitely many roots. Not possible. Ax is invertible for all x belongs to R. Means here you are saying that determinant of Ax is not equal to 0. Determinant of Ax in third degree polynomial must have root. So how it, and here you are saying that determinant of Ax is not equal to 0. False. Any odd degree polynomial will always have a root. So try to understand. I can answer this question whatever you want. I don't want you to think like that. Think like that. That's a different. And one more thing. Go through the basic part, try to understand and feel comfortable, and something is written here. Think about it. I think you got the difference. Your knowledge is important. It's not this exams and all. You can qualify that. But think about the next. What is next? You are able to qualify those interviews and all. Okay? So think about it. Because I think you deserve better. You should go to some premium shoot and do the extraordinary research on that. So think about it. And I'm always with you. Work hard, subscribe my YouTube channel, and